A master flat is primarily used to compensate for vignetting in your telescope's optics. Vignetting is where the brightness of the image dims towards the edges of your light frame. Localized dimming can happen if there is dust or fingerprints on the optics. This dimming can be expressed as a percentage. At the center of a light frame, 100% of the available brightness is present. Towards the edge of the light frame, vignetting causes this brightness to reduce significantly. With my setup, I'm seeing only 75% of the available brightness at the edges of my light frames. Please note, if you use a camera lens instead of a telescope, this video still applies to you. Consider the words telescope and lens to be interchangeable. In order to create a flat frame, you need to have a flat surface that can be very evenly lit. No variation in brightness or color is allowed. You're going to take a picture of this surface using your telescope camera assembly. This picture is called a flat frame, and we will be assuming that any variation in brightness or color in this picture is due solely to the optics in your telescope camera assembly. The better this assumption is, the fewer problems you're going to have when you develop your light frames. Not getting this right can cause dust motes or significant color or brightness gradients to be visible in your astrophotos. Some people use electroluminescent panels. Others have invented or purchased light boxes. CaLIGHTs has a light table feature which allows you to use your computer display as a light source. I use a second monitor plugged into my laptop for this purpose. The CaLIGHTs light table feature has an adjustable brightness and, most importantly, adjustable color. Only certain types of computer monitors seem to work using this scheme. I believe that monitors using an LED backlight work the best. Monitors that use a fluorescent lamp as the backlight may work, but I've had bad experiences with mine. With the CaLIGHTs light table, you need to ensure that your flat frame has an exposure time of half second or more to avoid screen flicker. You will need to bring your telescope close enough to your evenly lit surface so that it fills the image. With the CaLIGHTs light table, I bring the telescope right up to the monitor so that it touches the screen. You don't want to risk reflections from a table lamp or a window bouncing off the monitor and into the telescope. I also try to center the aperture of the telescope on the monitor. Some astrophotographers take what are called sky flats. Sky flats are taken of a cloudless sky as sunset approaches. They'll stretch white t-shirt fabric over the telescope aperture to diffuse the light. The downside of sky flats is that the sky is always darkening, so each flat is taken at a different lighting condition. You will need to be quick, otherwise there's too much variation in lighting between the first and last flat frame. Recently, I bought a B4 size light board on Amazon for less than $40. It is USB powered and very lightweight. Hopefully this year I'll get enough experience with it to post something about how it works for taking flats. My plan is to use the light board to take flats immediately after I've calibrated the mount and performed an initial focus. This typically happens when the sky is still darkening after sunset. I think it's an ideal time to get the flats and dark flats out of the way. Beyond using an evenly lit surface, there are several prerequisites that also apply, such as the telescope and camera must be assembled exactly as it was when taking your light frames. This includes any filters that are used. Filters are notorious for dust motes and fingerprints. This means you need to ensure that the filter is oriented the exact same way it was when you were taking your light frames, and that you've not tried to clean anything until after you've taken your flats. The camera must not be rotated to a different angle. The focus must not be changed. For most astrophotographers, this means that you don't disassemble your telescope camera arrangement until after you take your flat frames. I had typically carried the telescope camera assembly back into my house at 2 in the morning, and taking the flat frames the next morning. When taking flat frames, it's important to use an exposure that results in peak pixel values that are more than 50% exposed. You also want to avoid overexposing because those flats will be useless. Most DSLRs have a histogram feature. The values displayed are usually white balanced, which typically means that the red channel is shown to be double the magnitude of what the red pixel values really are. The green channel is shown exactly the way the green pixels are, and the blue pixels are shown 1.5 times of what the blue pixels really are. I know this sounds crazy, but even though there are a few assumptions in what I just said, there is a rule of thumb that you can follow. All this means is that you should check that the green channel is above 50%, but not greater than 80%. All you can do for the red and blue channels is to check that they are not above 100%. If you are using an Astrocam, you need to look at the values in your FITS files. Typically, these Astrocam FITS files have values that range from 0 to 65,535. 80% of that value is roughly 50,000. So you need to ensure that the values are close to, but not greater than 50,000. In many cases, you can take flat frames during the daytime. This means you can get familiar with taking flat frames during the day and also learn what camera settings work the best. When you use CaLIGHTs to create your master flat, you are presented with a graph that shows your raw pixel values in your flat frame. By default, CaLIGHTs will show you the red, green, and blue pixel values at the center of your flat frame, which is typically where the brightest pixels are found. Depending on the camera you are using, you can now verify if you're using the correct exposure. If you're using a 12-bit DSLR, then you are looking for pixel values that are close to 3200, but not higher. You also want to ensure that you don't see a bunch of pixels that are above 3200 and are all the same value. This is a clear indicator that these pixels are saturated. If you're using a 14-bit DSLR, then you're looking for pixel values that are close to 13,000, but not higher. Also watch for saturated pixels above 13,000. If you're using an Astrocam, you should verify that your peak pixel values in your FITS files are close to 50,000. You have to accept that you can't get the red, green, and blue pixel values to be equal. They will almost always be different. This situation gets even worse when you use filters, especially narrowband filters. The higher the pixel values are in your flat frame without saturating, the better the signal-to-noise ratio, or SNR, will be. You want very high SNR values for master flats because high signal-to-noise ratio means that the noise introduced into the calibration process by your master flat will be minimal. The easiest way to achieve high SNR values is to combine as many flat frames as possible into your master flat. I take 15 to 20 flat frames to create my master flat. Some astrophotographers will say that your flat frames should be taken at the same ISO or gain as your light frames. Others will say that a master bias frame can be used in place of a dark flat as long as the ISO or gain is the same. What is important to understand is that the flat compensation of your light frames requires 2 master frames. One of them has to be the master flat. The other master frame is required so that the flat compensation logic knows what pixel value in your master flat corresponds to 0 light. The ideal master frame to be used as a 0 light reference for flat compensation is called a dark flat. Dark flats are simple to take. You simply put the lens cap on the camera or telescope so that there's no light able to reach the imaging sensor. You then take your dark flats using the same settings as your flat frames. Bias frames are taken using virtually the same approach. The big difference is that the exposure time for bias frames should be as short as possible. If the exposure time of your flat frames is short, typically less than 1 second, then substituting a master bias in place of a master dark flat should work well. Just ensure that the camera ISO or gain is the same. Astrocam users will need to ensure that the offset value is also the same. When I take my flat frames, I also take dark flats immediately afterwards. This gives me the freedom to take my flat and dark flat frames at whatever ISO or gain that I please. Taking flats and dark flats this way makes this process a no-brainer. Master flats are used as a percentage multiplier, so the ISO or gain they are taken at is not important as long as you use a corresponding master dark flat or bias. Also, the lower the ISO or gain that you take your flat and dark flat frames at, the higher the signal-to-noise ratio becomes in each flat frame. Lower ISO or gain means that the camera needs to collect more light to reach the proper exposure. As the amount of light collected increases, so does the signal-to-noise ratio. This is because for an imaging chip, the signal-to-noise ratio associated with light increases with the square root of the amount of light collected in its pixels. Did you know that creating a quality master flat and dark flat is actually more important when imaging in light-polluted skies? Consider the possibility that your master flat is off by 1%. If you are imaging at a very dark site, your pixel values can be very small. A 1% error in a master flat will have a small effect because 1% of a smaller pixel value will introduce a smaller error. When imaging in light-polluted skies with the same camera settings, the pixel values will be much larger. That same 1% error in a master flat will result in a much larger error, making it hard to obtain a quality astrophoto without color gradients. Well, now you know as much about flat and dark flat frames as I do. These master frames are important to every astrophotographer. I hope this video helps you in some way. Thanks for listening, and clear skies.